You are looking at the pillars of creation.
The pillars of creation are a stellar nursery. New stars are in the process of being born in the central regions.
Located 7,000 light years from Earth, the pillars are part of the Eagle Nebula, which is just one of billions of star-forming regions in the universe. The pillars are towering clouds of dust and hydrogen gas. It's hydrogen, the lightest, simplest, most abundant element in the universe, that is the key component of stars. Within a nebula, clumps of this gas and dust slowly coalesce into smaller clouds over millions of years, pulled together by a very familiar force.
Thousands of stars you see when you look up at the night sky, every one of them is living in an interval between two collapses. An initial collapse of a dark interstellar gas cloud to form the star, and a final collapse of the luminous star on the way to its ultimate fate. Gravity makes stars contract unless some other force intervenes. The sun is an immense ball of radiating hydrogen. The hot gas in its interior tries to make the sun expand. The gravity tries to make the sun contract. And the present state of the sun is the balance of these two forces in equilibrium between gravity and nuclear fire. In this long middle age between collapses, the stars steadily shine.
5 billion years in the future, our sun will reach this critical crossroads. Its supply of hydrogen fuel will have been completely exhausted. Nuclear fusion will cease, and gravity will begin to crush the star. At that point, the situation is desperate. In order to survive, a sun-like star must find a new source of fuel. It has helium on hand, but in order to start burning helium, the core has to be 10 times hotter than it was during its lifetime burning hydrogen.
It won't be able to fuse that helium into heavier elements like carbon and oxygen until the core gets sufficiently hot. And that's because it's harder to get the helium nuclei close enough together for the strong nuclear force to take over, grab them, and cause them to fuse together.
As it continues to contract inward, nature throws the star a lifeline. The core actually becomes superheated by the very gravitational pressure that's trying to crush it. When it reaches 180 million degrees, it can start fusing helium into carbon in a desperate gamble to survive.